Dear student, we saw the previous lecture to show the series conversion or diversion, and that is comparison test. Now, second test, limit form test, which is summation un and summation vn positive terms. This is important. Positive term. This test is applied only for the positive terms. If limit n tends to infinity, un upon vn is equal to L, where L is a finite non-zero, means which is not 0. L not is equal to 0. Then un and vn converges or diverges together, means if vn converges, then un converges. Vn diverges, then un diverges. Okay. For this test, we must require convergence of hyperharmonic series. Hyperharmonic series means summation 1 upon n raised to p, which is 1 upon 1 raised to p plus 1 upon 2 raised to p plus dot 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 plus 1 upon n raised to p up to infinity, which is hyperharmonic series, which is convergent if p is greater than 1 and divergent if p is less than or equal to 1, which is convergent p greater than 1 and divergent is equal to p is equal to 1 or greater than 1. Okay. Let us see example. Suppose this series n raised to p upon 1 plus n plus 1 raised to q, where an is equal to n raised to p upon n plus 1 raised to q. Okay. Then we take the n outside. Then n becomes raised to power q. 1 plus 1 upon n raised to q. Then 1 upon n raised to q minus p. This becomes a minus indices raised to q. Here this is degree of n, and let bn is equal to 1 upon n raised to q minus p. To cancel this, n raised to q minus p, then limit n tends to infinity, an upon bn is equal to limit n tends to infinity. We get this upon this. If we get an upon bn, an this and bn is n raised to q minus p, then this get a cancel. There we get 1 plus 1 upon n raised to q, and this if we apply the limit, this is 0 and 1, which is 1, which is not equal to 0. Therefore we say that, what we say that? We say that bn 1 upon n raised to q minus p convergent. When convergent is, this is p test. We see the p test here, convergence of hyperharmonic series, which is also called as the p test. Greater than p is q minus p is greater than 1, and divergent if q minus p is less than or equal to 1. Okay. This convergent, therefore this series is convergent. This series is convergent. This series. Okay. Now next example, see the next example. An is equal to under root of n plus 1 minus under root of n upon n raised to p. Here we must take the n outside, or there is a conjugation. First we check the conjugation, then here conjugation is under root of n plus 1 plus under root of n upon under root of n plus 1 upon n. Then this becomes n plus 1 square minus n square, which is 1. Okay, which is 1. What? N plus 1 minus n, which is n gets 1, and this becomes, we take the n outside. Always we take the n outside. Then if we take the n outside, then it is 1/2. Then n raised to p plus 1/2 means n raised to here, n raised to p plus 1/2. This is therefore take this bn, means vn 1 upon n raised to p plus 1, and take this ratio an upon bn. An upon bn, we take this is cancel, and numerator denominator becomes, what is denominator? Here denominator is 1 upon 1 plus 1 upon n, and plus we take the limit. We get a 1. This is 1 and this is 1. 1 plus 1 is 2, which is not equal to 0. Therefore this p plus 1/2 is greater than 1. P, if convergent, when this convergent, okay, this is convergent if p plus 1 half is greater than p. This is all p. If this when this term convergent, if is greater than 1 means this 1 half becomes here p is greater than 1 half, and divergent if p is less than or equal to 1 half. If this convergent, this convergent means if this convergent, Bn is convergent. Bn when convergent Bn, if it is this power is greater than 1, then Bn is convergent, then An is a convergent. Okay, which is alternatively test. Now summation sine 1 upon n, which is we can write sine is equal to 1 upon n minus 1 upon 3 factorial n cube plus 1 upon 5 raised to n factorial, which is also right. Yeah. Or we can write limit n tends to sine 1 upon n upon 1 upon n, and Vn we take the Vn 1 upon n. If we take the Vn 1 upon n, this is not, then sine a, this upon this. What is sine this upon this? What becomes this n 1 upon n minus 1 upon 3 factorial n cube, and this is 1 upon n. And this becomes a numerator, and this is n cancel. Therefore, this factor, there is a 1. Okay, there is a 1. You can't. This is n or un. What is un? Un is 1 upon n minus 1 upon 3 factorial n cube up to, and this is Vn 1 upon n. We take the Vn. Why choose 1 upon n? This is 1 upon n lowest degree. Therefore, this becomes a numerator, and then this n in cancel here in cube is denominator. You see 0, all 0. If you take the limit apply, and this is 1. This is 1, which becomes 1. And 1. Therefore, this is their limit exists, but 1 upon n is divergent, but Vn is divergent, is p is equal to, therefore this is here is divergent. Okay, this ratio becomes a 1, which is finite. Then and Vn, what is the Vn? Vn 1 upon n is divergent, or why? Because p is equal to 1, therefore Vn is divergent, then therefore this is series is divergent. Okay, thank you. If you have any question, then comments me.